Hello everyone, welcome to this lecture series on thermodynamics. In this series of thermodynamic processes, we are going to study another two processes, namely reversible and irreversible process. First, let's see what is meant by a thermodynamic process. We have seen in the previous series also, a thermodynamic process is a chemical or physical process that takes place in a thermodynamic system which changes the system from an initial state to a final state. Here, the system returns to its original state when all the physical properties resume their original values. There are different types of thermodynamic processes. Among them, today we are going to discuss reversible and irreversible processes. So, in order to understand reversible and irreversible processes, first let's try to understand what are the different types of changes. So, all the changes which are available in nature are of two types, reversible changes and irreversible changes. First, let's see what are reversible changes. So, a change which can happen backward or which can be reversed, as the name itself indicates, it's a reversible change. That is, a change which can be brought backward is called a reversible change. So, a change which can happen backward or which can be reversed is called a reversible change. For example, if we keep water in freezer for some time, then it gets converted into ice. But as soon as we take it out of the freezer, then once again it gets converted into water. So this is the reversible change. So water is converting into ice, ice is back converted into water. So the initial state is getting existing. Now, similarly, if we allow the water to boil, then what happens? The water, after boiling, it gets evaporated and converts into water vapor. When we cool this vapor, it again turns back into water. So here you can see the reversible change. The ice is getting converted into water. Once again, on heating, on cooling, what happens? This water is being converted into ice. So this is the example here. So this is the reversible change. Now let's see what are irreversible changes. Irreversible, that cannot be reversed. So a change which cannot happen backward or which cannot be reversed is called an irreversible change. For example, if we burn a piece of paper, then it gets converted into ash. Then this ash cannot be converted into paper again. And another best example is our height. We cannot decrease our height. So next, these are the best irreversible changes. So they cannot be reversed at all. Another example is when we take an egg and allow it for cooking in order to have an omelette, then what happens? It gets converted into omelette, but the reverse is not possible. We cannot get the egg back. So these are the irreversible changes. So we have understood what is meant by a reversible change and what is meant by an irreversible change. Now let's see the reversible and irreversible processes in thermodynamics. So first one is reversible process in thermodynamics. So a thermodynamic process is said to be reversible if the process can be turned back such that both the system and the surroundings return to their original states with no other change anywhere else in the universe. So in the reverse process, the system passes through the same stages as in the direct process, but thermal and mechanical effects at each stage are exactly reverse. If heat is absorbed in the direct process, then what happens? It will be given out in the reverse process. Similarly, if work is done by the system in the direct process, then what happens? The same amount of work will be done on the system in the reverse process. Hence, the system will restore to the original state. So, in order to come back to the initial state, if once heat is absorbed in the direct process, then the same amount of heat must be given out in the reverse process in order to attain the original state. Another example is when ice melts, then it gets converted into, by absorbing such an amount of heat, it gets converted into water. Then the same amount of heat is removed for the ice to be converted back into water. So this indicates that many reversible processes are non-spontaneous processes. Now let's see some of the conditions for reversibility. A process can be reversible only when it satisfies the two conditions or these following conditions. Here, there should not be any dissipative forces such as friction, viscosity, and electrical resistance. That means these dissipative forces should be completely minimized. And the direct and reverse processes must take place very slowly. All the initial and final states should be in equilibrium with each other. That means the temperature of the system must not differ from the surroundings. Then only we can say that the system and the surroundings are in equilibrium state. So these conditions are essential in order to carry out a reversible process. But however, in reality, this is not possible. That means no such processes as reversible process can exist. Thus, the reversible processes can easily be defined as the idealization or models of real processes on which the limits of system or device are not to be defined. That means there will not be any reversible processes in reality. This is only an ideal one. This is only an ideal one. Of course, this idea helps us in incurring the maximum efficiency of a system which can provide an ideal working condition and thus the target design that can be set. This idea of reversibility is also useful or very useful in calculating the mathematical problems. Now let's explain the reversible process. So we have understood that during the reversible process, all the changes in state that occur in the system are in thermodynamic equilibrium with each other. Thermodynamic equilibrium with each other. That means the system and surroundings are at the same temperature. That means in simple words, the process which can reverse back completely is a reversible process, which implies final properties of the system can perfectly reverse back to the original properties. The process can be perfectly reversible only if the changes in the process are very, very small or infinitesimally small. Here you can see that when the gas is allowed to expand, by moving the piston upwards, then what happens? The gas is being expanded. Here the gas is expanding, so the gas is expanded to the full. Now two stages of expansion is taking place. Here once again, when the gas is allowed to compress, then volume gets decreased. On further compression, the volume further decreases and reaches the original state. So here two stages of expansion is there. Similarly, in order to attain the original state, there should be two states of compression. That means if some amount of heat is added in the forward direction, the same amount of heat must be given out in the reverse direction in order to attain the original state. Similarly, if certain amount of work is done in the forward direction, the same amount of work must be done by the system on the surroundings in the reverse direction in order to attain the original state. So this is the reversible process. Now let's see some of the examples of reversible processes. So all the isothermal and adiabatic changes when performed slowly are reversible. So slow isothermal and slow adiabatic changes are examples of reversible process. Similarly, very slow expansion and compression of any gas. Very slow evaporation and condensation of gas is another example of reversible process. And extremely slow evaporation or condensation is another example. Similarly, when certain amount of heat is absorbed by ice, it melts. If the same amount of heat is removed from it, the water formed in direct process will be converted into ice. So these are the examples of reversible process. Next, we will go for the next type of thermodynamic process, which is irreversible process in thermodynamics. So the process which cannot be carried out in the opposite direction by reversing the controlling factors is called an irreversible process. So we know that during an irreversible change, the system is not in equilibrium at all instants of time. That means the temperature of the system and surroundings will be different. The irreversible process consists of non-equilibrium states which cannot be represented on a PV diagram. All the changes which occur suddenly or which involve friction or dissipation of energy through conduction, convection or radiation are all reversible processes. So irreversible process in thermodynamics. See, this irreversible processes is also called the natural process because all the processes occurring in nature are irreversible processes. So the natural processes occur due to the finite gradient between the two states of the system. For instance, heat flow between two bodies. Heat transfer between the two bodies can be considered as the best example for irreversible process. We know that heat always flows from a body of high temperature to a body of low temperature. That means there is temperature gradient between the two bodies. This is in fact the natural flow of heat. That is the process of heat transfer, and this is the best example for irreversible process. Similarly, water flowing down a hill on its own accord is an example of irreversible process. Another example, best example is biological aging is an irreversible process. In the previous slides, we have seen that the height of a person cannot be altered. So similarly, the biological aging, the age of the person cannot be reversed, is an example of irreversible process. And also the current moving from high potential to low potential. So there is finite gradient between the two states of the system. So irreversible process in thermodynamics are, so we know that most of the natural processes are irreversible in nature. Now, let's have a look at some important points about the irreversible process. In the irreversible process, the initial state of the system and the surroundings cannot be restored from the final state. That is, we cannot come back to the initial state. So all the changes which were made in the forward direction cannot be retraced to the backward direction. Next, during the irreversible process, the various states of the system on the path of change from initial state to final state are not in equilibrium with each other. That means there is temperature, they are not at the same temperature. During the irreversible process, the entropy of the system increases decisively and it cannot be reduced back to its initial value. Entropy means disorderedness of the system increases. Next, the phenomenon of the system undergoing reversible processes is called irreversibility. Next, we can explain the irreversible process here. So, an irreversible process is a process in which there will not be any equilibrium. So, equilibrium, the changes of pressure and volume, it occurs when the pressure or the volume of a system changes dramatically and instantaneously, that the volume or pressure do not have the time to reach the equilibrium state. Here, we can consider the classic example of an irreversible process by allowing a certain amount of volume of gas to release into vacuum. By releasing the pressure on a sample and allowing it to occupy a larger space, the system and surroundings are not in equilibrium during the expansion process. Here, a very little amount of work occurs, and however, there is a requirement of significant work with a corresponding amount of energy dissipation as heat flows to the environment. So this is in order to reverse the process. So in the case of an irreversible process, the final state, we cannot attain the initial state after reversing the process. Now let's have a look at the examples of irreversible processes. Heat transfer between the two bodies is the best example for irreversible process. Sudden expansion or contraction of gas is another example. Rapid evaporation of water and fast condensation of ice. The conduction of heat from a hot body to cold body. Transfer of heat by the process known as radiation. Production of heat by friction. Producing of heat by passing of current through an electrical resistance. An explosion is another example. Inelastic deformation is another example. Magnetization or polarization with a hysteresis. Spontaneous chemical reactions. Spontaneous mixing of the matter of varying stages. And also, when a steel ball is allowed to fall on a rough surface, then certain amount of kinetic energy is converted into heat energy, but reverse is not possible. These are the examples of irreversible process. Now, let's see the differences between reversible process and irreversible process. So, in the case of a reversible process, we can say that it is a slow process going through a series of small stages with each stage maintaining equilibrium between the system and surroundings. So with each stage maintaining the equilibrium, thermodynamic equilibrium, temperature of system and surroundings will be same. Here in this process of irreversible process, the system attains final state from the initial state with a measurable speed. During the transformation, there is no equilibrium maintained between the system and surroundings. Coming to the reversible process, a reversible process can be made to proceed in both the forward direction and the backward direction, forward or backward direction. Here, whereas in the case of irreversible process, it can take place only in one direction, but the reverse is not possible. Here, the driving force in the case of reversible process, the driving force for the reversible process is small since the processes proceed in smaller steps. Here, there is a definite driving force required for the progress of irreversible process as it takes place at a measurable speed. Work done in a reversible process is greater than the corresponding work done in irreversible process. Work done in a irreversible process is always lower than the same kind of work done in reversible process. A reversible process can be brought back to the initial state without making any change in the adjacent surroundings. An irreversible process cannot be brought back to its initial state without making a change in the surroundings. So these are the differences between reversible and irreversible processes. So by going through this video, I hope you have understood what are reversible and irreversible processes, examples of reversible and irreversible processes, and you are able to differentiate reversible and irreversible processes. Thank you.